Do you collect rocks and minerals, or maybe you used to? Do you ever pick up a rock just because it looks cool or unusual? Maybe you have a rock garden, use stones for decoration, or even have a pet rock? Many of us wear jewelry made with minerals like diamonds, gems, or crystals. Rocks and minerals are everywhere in our lives, but have you ever stopped to wonder, where did they come from? How were they formed? Well, that's what this video is all about, so let's dig in. Think about it. What have you done today that did not involve a mineral? Really, take a moment. Have you brushed your teeth, checked your phone, got dressed, or ate breakfast? In one way or another, minerals were part of it. In other words, what have you done today that did not involve a mineral? Well, the earth is built from elements, and those elements combine to form minerals, and those minerals come together to form rocks. These natural materials are the foundation of our world. Almost everything we use, touch, or depend on can be traced back to the raw materials of the earth. This is a story of how the elements of the periodic table and the minerals they form fit into the rock cycle. Elements are the basic building blocks of everything on Earth, including rocks and minerals. Each element is made from a single atom and cannot be broken down into simpler substances by ordinary chemical means. There are 118 known elements, and of these, 92 are naturally occurring, from hydrogen-1 to uranium-92. The remaining elements have been produced in laboratories. On rare occasions, elements can occur in pure form on Earth. These include metals in solid form, such as gold, silver, and copper, and nonmetals like carbon and sulfur. In these cases, many atoms of the same element are bonded together. 8 elements are commonly found in rocks and minerals of Earth's crust, and they make up nearly 99% of the crust composition. They're all listed here. Minerals form when elements combine in a regular repeating pattern known as a crystal structure. The International Mineralogical Association currently recognizes over 5,800 distinct minerals. Some are common and found worldwide, while others might only occur in a single location. A rock is a solid mixture of multiple minerals. There are 3 broad categories of rocks based on how they formed: igneous, sedimentary, and metamorphic. Thousands of different types of rock exist on Earth because they vary not only in how they are formed, but also based on the type and amount of each material. The rock cycle illustrates how one rock type can transform into another over time. Igneous rocks serve as a starting point in the cycle and can be broken down to form sedimentary rocks or subjected to heat and pressure to become metamorphic rocks. To create minerals and rocks on Earth, and when looking at the rock cycle, that starts with molten material. To illustrate how minerals are added to the rock cycle, we have added detail to the rock cycle. Our version begins with hot molten material beneath the Earth's surface, rich in various elements, and under pressure. As this hot material uplifts and migrates upward, it cools and solidifies near or at the surface as an igneous rock. Fun fact is that magma is the molten material beneath the Earth's surface, and lava is magma that has erupted onto the surface through volcanoes or fissures. During the ascent of the molten material, it can interact with gases, water, surrounding rocks, and even microbes. Depending on its chemistry and cooling rate, specific minerals will begin to crystallize out of the melt. Sometimes the magma is trapped underground and solidifies as an intrusive rock. Other times it forms on or near the Earth's surface as an extrusive rock. Granite is a type of intrusive igneous rock that forms deep underground as magma slowly cools and solidifies. It is composed primarily of feldspars, the most abundant mineral group in Earth's crust. Quartz, the second most abundant, and smaller amounts of other minerals like mica. In contrast, obsidian, or volcanic glass, and pumice, a rock that can actually float, are examples of extrusive igneous rocks which form when lava cools quickly at the Earth's surface. We have noted the term geobattery to highlight that when minerals and rocks form from cooling magma or from hot mineral-rich water deep underground, called hydrothermal fluids, ions, those charged particles, move through these fluids and into solid crystals. This movement of charge can create natural electrical gradients, which may influence how minerals form and even drive electrical currents. Igneous rocks can be broken down into sediments, which then may form sedimentary rocks, or they're transformed into metamorphic rocks. Weathering is one key process in these changes and can be accelerated by a biological activity, including the actions of humans, animals, plants, birds, and microbes. During weathering, rocks are essentially being recycled and new minerals can form as a result of chemical changes. For example, the feldspar minerals in granite could be broken down into new clay minerals like kaolinite. In fact, at any part in the rock cycle, weathering, erosion, water, and air transportation can lead to supergene enrichment, which results in new minerals. This refers to geological processes enhancing the concentration of valuable minerals like gold, copper, and uranium. The figure shows a classic example from the Athabasca Basin in Saskatchewan, where groundwater movement has concentrated uranium to levels up to 100 times higher than anywhere else on Earth. Rocks can also be subjected to increased pressure and heat through burial and compaction. When these conditions become extreme, rocks can melt and form magma. A simple example of the melting process is ice melting into water due to heating. Ice meets the definition of a mineral because of its solid crystalline structure. This melting also occurs deep in the Earth's crust at plate subduction zones, where rocks are transformed back into magma. When pressure is applied to sediments over a long period of time, the loose particles can be compacted and cemented together to form solid rock in a process known as lithification. If minerals are dissolved in water, they can precipitate. That is, they can come out of solution and form solid crystals when conditions change, such as when the water evaporates or cools. The potash deposits of Saskatchewan formed this way when an ancient ocean dried up and left behind layers of mineral salts as crystals. We've reimagined the rock cycle to include not just minerals and elements, but the modern human's touch. Today's cycle is shaped by extraction, mining, and industrial processing. We are mixing materials from all over the planet in ways nature never would. We are creating new human-made minerals and geology. As we finish this off, we remind you of the question we asked at the start. What have you done today that did not involve a mineral? We walk on rocks, build our homes and roads with them, craft tools and technologies from the elements within them, admire minerals for their beauty, and even rely on them to grow our food. We could have changed the word mineral to rock, or we could have changed mineral to element. However, we chose mineral because minerals are the essential link. Minerals are made of elements and make up rocks. They're the building blocks of the solid earth and the materials we rely on and use every day.